Okay, so we will start. Hello, everyone. Today, our second webinar, which we organize in Data Phoenix to support Ukraine and together with Scholar Fund raise money for our Ukraine army. Through the Scholar, we provide to our army high-tech equipment for the front line. So we welcome all to donate and help Ukraine and Ukraine army be more strong. And today help us, sorry.
Shalini, no problem.
Yes,
Shalini, no,
yeah,
it's not a common name. Yeah.
Yeah, she is co-founder and CEO of Clearbox AI. And today she will tell us about synthetic data, how to work with them, how to understand the quality of this data. So I give to you microphone, and you can start. Sorry. Sorry. The questions you can write as on previous webinar in the Slack, or you also can connect to us in the Zoom, and let's do live discussion after the presentation. I hope it will be interesting. Yeah. Now your microphone.
Thank you. Thank you very much, Dimitri. Really great to be here and also to be part of this fantastic community. And also the cause is very noble. So I'm very, very happy to be part of it. And today I'm going to speak a little bit about synthetic data. Obviously, it's not a coding workshop. We are going to talk about what is synthetic data and how are we going, why is it such a hype nowadays, and what are its applications. And today's talk is about responsible innovation. So we will not only focus on the actual aspects, which is synthetic data nowadays is being used for in terms of privacy, but also we're going to talk about fairness, bias, and how can we actually improve it. So I'm going to share my screen at the moment. I hope you can see my screen. Please let me know if you can't. Do you see my screen? And that's like the question everybody asks nowadays.
Yes.
Is it okay? Perfect. All right. So we're going to talk about the promising role of synthetic data. I'm sure if you're in the data community nowadays, synthetic data, there's a lot of news about it, a lot of hype about it. So today I'm going to kind of unravel a few of that, a few of those ideas. And obviously, I'm not going to assume that everybody knows about synthetic data. So I'm going to give a context about it. And today's webinar especially is about responsible innovation. We can't cover everything, of course, but we're going to talk at least about some aspects of it. And I am Shalini Kurapate. I am the co-founder and CEO of Clearbox AI. Obviously, if I am talking, I cannot just talk about myself. It's I am leading a company called Clearbox AI. We are a synthetic data startup. Together with my co-founders, we started this company a couple of years ago, and we started doing synthetic data since last year as our main let's say our main objective, and we have a product about it, and we all come from the university. We are engineers by training, and I, for instance, I have a background in data management, data privacy, and ethics, and Luca, for instance, works in machine learning and uncertainty quantification, and we have software architects, and we have Matteo, for instance, works more on the operations. So we are the founding team, and we work with other team members. One of my team members, Alessandra, is also joining me here today. She works mostly on, like talking about us, helping us communicate our thing. And mainly we work in the energy, banking and finance, and some healthcare projects. And it's an industry agnostic company, and also in industry 4.0. We have several already collaborations, and we work mainly with at the moment, we're working with banks and insurance companies in providing synthetic data for a number of purposes. So that's who we are. I never say I, it's always we, obviously. So that's who we are. So for people who are completely new to synthetic data, what is synthetic data? Synthetic data can be a lot of things, even like GANs, or you could think of simulations, you could think of digital twins. You could call a lot of it synthetic because it's artificially generated. But the synthetic data, what we are going to talk about is more like a clone. Like you take the original data and you estimate the distribution through an AI model, of course, and then you get synthetic data, which is statistically similar to the original data, but there are differences in terms of, for instance, if the original data contains personal data information, the synthetic data might not have a one-to-one identification of the personal attributes. There might be other similarities, but in terms of privacy preservation, it could be one step ahead with respect to, let's say, anonymization techniques, because if you anonymize a data set, you might remove a lot of information, you might remove a lot of statistical properties, and you might still have other privacy risks. With synthetic data, you can maintain the utility of the data set while guaranteeing privacy. So it's kind of a mechanism in terms of privacy. And also in terms of data quality, for example, you can create synthetic data sets. If a company wants to start building AI models and they have very little data set to start with, they can use synthetic data set to augment their data for more testing. So it's some kind of a data on demand as well. So you can start populating your synthetic data space, for instance. So that is basically synthetic data, and there are many methods to do it. And obviously, we have our own technology that develop synthetic data. So what we essentially do is that we take original data sets. It could be a transactional data from banks or customer data or client information. All the and the end goal could be predicting the churn rate of customers, or whatever the end goal is. The kind of data that we get, we can first we profile the data set. We do a sanity check, how good the quality is. Is it good enough to do a synthetic data set? And then we, using our solution, we generate the synthetic data. We not only generate the synthetic data, but also we provide data quality metrics. So how good does this perform on the model, like train on synthetic and test on real? Like what is the comparison between the two? And then that is the utility metric. So how useful it is. And then we also have a privacy report, because this is not just for our own solution. For any anonymization technique, synthetic data could be considered one of anonymization technique. You have different kinds of privacy risks. Just because you remove name, surname, or gender or postcode doesn't mean that it's anonymous, because you could have attribute risks, or you might have inference risks. So, and especially nowadays with AI technologies, if you have a lot of pattern recognition. So even without any personal data attributes, you can kind of understand how a person behaves, what kind of aspects they do in their daily lives, etc. So for each of these risks, you do need some kind of a quantification of these metrics. So we also quantify all these privacy risks as a solution. So this is kind of a way to build synthetic data and also give insights. So you can not only talk to your data scientist, but also to your privacy officer, your risk officer, to understand, can we move this data from one company to the other? And we see a lot of use cases for synthetic data. You can have even within companies. I'm sure if you're working with data, getting access to real data sets is very difficult, even within companies, because maybe one department has, there's some organizational silos about, can I share this data, especially when personal data is involved. And then if you want to test a new feature for a software, you might need real looking data, but it's always difficult to get real data with real customer information, especially when you're talking about GDPR constraints. And then you also have the issue of training your AI models. So because we all know that how long it takes to have production ready values, and By now, Andrew Ng's data-centric AI has become already old news, where he says that 80% of the time, data scientists spend time on collecting data, cleaning data, making sure that it's production ready, and that still holds. And having access to good quality production ready data to test the models, to test your AI models, synthetic data could be very useful. This is already within companies. Again, also outside the companies, even sharing your data sets. Let's say if you're a big company, you have a contractor and you want them to build something for you, and you do want to give them a real data set for it to work very well, but you can't because of a number of issues that we talked about. So sharing this data between company to collaborate or to kind of innovate, you can think of open innovation projects, or if you want to do a hackathon, if you want to give this data set outside your company, synthetic data could be a good alternative. And obviously for research, and to some cases also monetizing the data while being responsible with respect to personal data attributes. So there are so many use cases for synthetic data. So that's why we build this. If you're interested to know how we do it, there are many ways to do it. How we do it, there are free ways of getting in and logging in. We have the demo online, which is you can log in for free and try out what I just told you about, or you can upload a data set and you can see what a synthetic data looks like with all the privacy metrics. We also have an open source project on GitHub, which is more about data profiling, to actually write tests for data to check their quality and to improve data quality. So both of them are freely available. Please, if you're curious to know what we do, you're very welcome to look at it. So this is just a little bit of introduction about myself, what we do at the company, and what is synthetic data. Now let's get back to the more applications of synthetic data. Back to synthetic data. So why is this so important nowadays, and why are we making a very important webinar about this and talking about synthetic data? If you have looked at the recent Gartner hype cycle of artificial intelligence 2022, which was released last month, actually less than a month ago, they look at the trends of AI, and they categorize it into data-centric AI, model-centric AI. Model-centric AI is more about efficient models, energy-efficient models, combining different models to make sure that they don't need massive computational power. Then you have application-centric AI, which are more about decision intelligence, autonomous vehicles, or edge AI with IoT embedded, AI embedded sensors, for instance. And then you have human-centric AI, which is about ethics and security and trust and responsibility. So these are the, let's say, the trends that are predicted, of course, and we fall more on synthetic data. I think falls between data-centric AI and human-centric AI as well in this equation, especially what we're going to talk about. And according to Gartner and also some marketing trends, in the next 2 to 5 years, it's going to reach its peak of productivity. That's according to the predictions, and just before this trend of talking about why synthetic data is going to be so important, in 2022 the MIT Technology Review also talked about synthetic data being one of the biggest breakthroughs. And many were confused. Hey, synthetic data is not so new. It's been there for a long time. So why are we talking about it now in 2022? And that's also one of the reasons is that another estimate also is that by 2030, the majority of the data that will be used for AI is predicted to be artificially generated. So either from, like I said, many different ways of creating synthetic data. It could be rule-based, simply rule-based, or statistical modeling, or simulations, or just or even GANs, for instance. Or the main reasons is that, for instance, if you think about autonomous driving, it's impossible to get the data sets from real life for every single situation. So most of the time, if you look at NVIDIA, their work on synthetic data is really about artificially generating environments, synthetic environments for autonomous, for training, or driverless cars, for instance. So this is just to give you a quick feeling of why synthetic data will be very important in the coming future. So, and one of the main reasons, this is from an article and also a few other surveys from data scientists who talk about the issues of a lack of production-ready data sets for a number of reasons. And many of the ML projects, machine learning projects, they fail because there's not enough data to test. And even if they don't fail outright, many of these projects, they are delayed for months. So obviously, there is a lot of shift from the model-centric to data-centric AI, and synthetic data, like Gartner was saying, plays a very key role in accelerating these projects. And the two main reasons as of today, what people use synthetic data for, one of the main driving forces for this is privacy, data privacy. Absolutely, it's considered as one of the it can be considered not just as an anonymization technique, but also a privacy enhancing technique. That means you're doing it by design. By design, when you build AI models, you're not using personal data, but you're using synthetic data, and you're preserving privacy by not using the raw data. And also for data sharing, and you have laws like GDPR. People who live in Europe, or they know very well about GDPR. It's not just limited to Europe, but any country that does business with Europe has to, comply with this. So, and also there are also American laws like the California Consumer Privacy Law, for instance, also, or the HIPAA, the Healthcare Privacy Act in the US. So for all of these aspects, synthetic data is very important. And if you look at the census, most of the census authorities, the US Census or the Irish Census authorities, all of them do have synthetic data sets to give out to researchers to work with it, also because of the privacy reasons. And the other reason which synthetic data is extremely important for is data augmentation. Like we talked about, we have class imbalances, and we have, for generalization issues in machine learning models, it improves the performance because of this aspect of on-demand generation for testing and more testing. So that's one aspect. So just to give you an overview of the recent statements from especially regulatory bodies about synthetic data, many of them, right, from Europe, UK, Canada, talk about synthetic data to be a driving force for privacy preservation for AI. And the European Data Protection Supervisor's spokesperson went one step ahead, saying that is the future of AI privacy synthetic. So that's the level of one. And most recently, if you're interested, the Joint Research Center, the JRC, which is the European Commission's very prestigious research center, they published a report about different privacy preservation technique, and they have concluded that synthetic data has the best value and effort performance. I just told you about the utility and privacy, right? If you have too much privacy preservation, you might have less utility in terms of predictive power. So this kind of balance, according to this report, is very much preserved for synthetic data. So this is about what is currently, let's say, the state of the art for the application of synthetic data. But one of the interesting aspects, or the lesser known side of synthetic data, is the bias mitigation. Here, I would even expect a question before I go. You might even say, doesn't synthetic data propagate bias into when you have a biased data set? And if you clone it, won't I have a biased data set? You might have this question. Yes, it could be possible, but there are ways, or actually you can turn the coin and say, I know how to clone a data set and understand the properties of each of these data sets. I can actually mitigate the bias using synthetic data. So now the lesser known side of synthetic data is actually understanding if we can reduce the bias and increase fairness in data sets. So that's what we're going to talk about. That's the new aspect, what we're going to address at the moment. So if you have been working in the AI domain, even if you open the newspaper every other week, you will have some news about AI is being biased, algorithms are discriminating based on a number of aspects. So the oldest one and the most common one is the Amazon recruiting tool, which discriminated women, even though the CVs were completely anonymized, and the algorithm understood that this person was a woman or a man just based on their hobbies or the schools that they went to. And they were discriminated against because historically men were more in the workforce. So that was the historical bias. So even with the same, let's say, qualifications, men were preferred, and they could not do anything. They had to really cut off the project. And then there are a lot of discrimination based on gender, of course, and also based on the background, based on ethnicity, based on race, because of issues of generalization also, because we don't have enough data that represents every population. And then you have Apple's credit card, which was also a bit of a media disaster for them. Even Steve Wozniak had the problem that his wife had lesser credit score than he did, even though they had the same joint account. The only difference was she was a she and he was a he. So and then there are and the most let's say sensational one is the criminal the predictive algorithm of the risk of reoffense. It was called Compass by the US in the US, and there, if you look at this picture, there were two people with similar offenses, and the risk of committing an offense again was given to the person of color compared to the non-person of color. So, and also there are other kinds of discrimination, not just based on gender, but also in terms of people ranking based on their performances, which is not necessarily based on gender or race, but it's about human rights. So you have different kinds of discriminations, different kinds of biases, because these biases don't just appear in the algorithms. It comes from us, human beings. And today is not a philosophical lesson. If we talk about biases, we can talk about it for hours. It's a very complicated concept. But today, let's try to be, codify what this means. So I'll just give you an example of how these biases might creep into models. For instance, in this example, you can see that the symptoms of heart attack for a man are very different. So it means that the chest is being pressed and they cannot breathe. So that's the symptoms for a man. And for women, the heart attack symptoms are very different. It could be back pain. It could be feels like, I don't know, a general malaise rather than, so the symptoms are very different for men and women sometimes. But historically, most of the medical corpus has been based on studies on men. So all the data that the models that we can train about diagnosing or predicting might be based on data, accurate data, but the data collected, the studies that were not done on everyone. They were done predominantly on Western men, Anglo-Saxon men even, in terms of all the main corpuses, especially if it's in English. And so there was a company, I don't want to name the company, who developed an algorithm to predict, to diagnose something when you put your symptoms inside. So when a man put the symptoms of his heart attack, immediately the algorithm said, this is an emergency, you need to go to the hospital. And a woman who put heart attack symptoms said, and the algorithm said, it's a panic attack, calm down, take it easy. So this, of course, it's a dramatic example to show the harm biased algorithms can do. not just about refusing a loan. Obviously, the harm is like if they tell you that you're going to commit a crime, all that will create great harm. So this is the level of impact that biased algorithms can have. So this is to give you the context, right? So if you give you a map, so biases can come from, obviously, they come from us, of course. But when you think of a machine learning pipeline or a process, the bias could be from data sets. So how the data sets were collected, the quality of them. Some of them are out of our control, obviously. It's not like we can go and collect the medical characteristic of everybody as data scientists. And then you have from the general data collection itself, when you develop data set, and then also while labeling them. So there are a lot of biases that can creep in. And then obviously the data feeds into the model and how we build the models also, right? So in terms of how inclusive these algorithms are. So while building the models, how do we evaluate them? How do we make them explainable? Or all these things will influence about how good or biased or fair the algorithms are. And then how are we using this? If we are using an algorithm to detect I don't know, cracks in a cup in an assembly line with a computer vision algorithm, who cares if it's biased or not? As long as it detects the cracks and saves time and, my assembly line is more efficient, it's fine. But what kind of use are we going to do with it? If we're going to use it for, rating people or evaluating people based on that, or at least telling them whether they're going to commit crimes or not, or making them deciding whether they're going to get a mortgage or not based on, and those kind of uses are the ones which we have to talk about. For the uses that don't have a direct impact on people's lives, this might not be a big problem. If personal data is not involved or people's lives are not involved, bias might not be a big issue. We have other issues like how computationally efficient the algorithm is what size of data sets we need or not. And then if we have these biases, there are so many issues we talked about. I gave you a few examples of how these biased outputs of algorithms happen. So this is kind of the hazards of biased AI systems if we use for high risk situations, like some of the examples I gave, healthcare, having a mortgage, criminal justice system, CVs. And nowadays, children are being also evaluated using algorithms based on their data in some examples. So all these things, how is it going to affect them, and how is it actually fair, And that's an interesting question, right? So here we talked about all the things I talked about in terms of bias. It can be categorized as a statistical or computational. Whether it's about building an AI model correctly or making data quality better, all that I would say it comes in the statistical and computational side of things. But where is this bias coming from? It comes from humans, it comes from society, it comes from a lot of factors. So it's not just one individual aspect. So this is something we have to always remember when we talk about bias. And the National Institute of NIST, the American Institute for that publishes a lot of standards. They have a very nice paper about this. I welcome you to check it out, about how do we deal with these interconnected biases. So that's to give you the context. And like I said, we can't look at every single bias. So today, let's talk about the biases that can happen in data and how can synthetic data help with that. And this is from the Google's machine learning course on fairness. So they talk about on the data side, you can have reporting bias. That means that when we collect data, people who report it might only report the things that they find interesting. And then there's the selection bias. And then there's overgeneralization, and then there is no nuanced information, so it's homogeneity bias, and then confirmation bias. That means that when we collect data, we believe things that we already know are true, and then there is automation bias. So there are many biases on the data side that comes from humans, society, a number of things. So and now that we talked about biases and where they come from, so how can synthetic data help here? So I'm going to give you an example. So before we know synthetic data, we do need to know what does bias or fairness mean in reality. So all this is very philosophical, high level, yes, but if we have to build an AI model or test for data, so what are the metrics or at least some kind of measure that I can use to test whether this data is good, bad, or fair, unfair, just, unjust, whatever it is. So there are many of the metrics of fairness metrics. One thing, some people use the word notions instead of metrics because the whole point of can we actually measure fairness? Is it actually, it's an oxymoron, right? Yeah, measuring fairness. Fairness is so subjective. Can we actually measure it? So some researchers use the word notions. Some practitioners use metrics because it's easier to understand. So basically, the main metrics are based on group fairness metrics. That means whether it's related to gender, whether it's related to a demographic, like whether they live in a certain postcode, or whether they belong to a certain community, or do they belong to a certain ethnicity or race. So the group fairness are the most used ones. So to check whether this algorithm is being biased against a certain gender or a certain ethnicity. And then you also have individual fairness, of course, that like you have to be sure that similar people are given similar decisions, etc. And then you also have counterfactual fairness. It's also, if you are working with explainable AI, it's similar to counterfactual explanation. So when you, I don't know, when you rejected a loan in a bank, what is the condition that is required for me to get the loan? And that condition should not be just because you're a woman or you're a person belonging to that postcode, but it should be much more like, oh, the salary of this person should be a bit more. So something like that. So counterfactual fairness is similar to that. So I really recommend you, if you are new to the fairness metrics, there's a free online book called Fair ML Book. One of the co-authors is Arvind Narayanan. There are so many fairness metrics. I think he talks about 21 of them, that there are a lot of them, of course, and they're evolving. There are no one set principles of fairness metrics. It can be overwhelming in the beginning. What is the fairness metrics I need to choose for my data set? But have a look at it. It's a free book. You can kind of understand both also the opportunities of using it and also the limitations, because I told you these metrics, I would consider it to be more notions for you to have a framework about how to test your data sets. So in our case, today's example, let's consider the measure for fairness in terms of gender. Okay, today let's consider the group fairness metric as gender. And the two important fairness metrics for this, we could consider, one is called the equalized odds. That means that the predictions are, that means the total positive rate of predictive power of the model is equal across different groups. And the equal opportunity means that it doesn't matter about it doesn't matter if the TPR is independent of insensitive feature. It should be the same across every group, irrespective of their proportions of the population. So to give you an example, let's take a data set. We can take an adult data set, the most common one that all data scientists use when they start working on Kaggle, the census, income, and if you consider a binary classification and an XGBoost model. So we have the target is the income. So they have to predict what is the income of this. The model has to predict the income for a certain individual. And here we have sliced this into age greater than 60 and gender female for every age, female and male. And so we have like 6 slices. We can do that. And once we make the slice and we make the predictions, and you can see that the TPR of each of the slices is heavily is much higher for men. Like for instance, in this category, it's 3 times, and here it gets worse. Like it's 0.4 positive predictions, and here it's only 0.1. And sorry, and then after age 65, it becomes even 0 for females. So it's the positive prediction rate reduces drastically, and so here we can see that the model is actually predicting is biased against women in this example, because it's always predicting higher for men, and we have to check whether that is true or not, and the TPR shows that that's not always the case. So what we do is for this particular example, what we can do is we can generate synthetic data points to populate some of the data slices we see. We can also make multiple data slices to check how the model is performing across different categories. You could also make it with postcode. You can use any protected categories that you consider to be like in the fairness system. And then for this particular example, for instance, what we did was we populated women with high earning women within the 42 to 90 range. That's where the TPR was bad. And in the original data set, for example, when we did this repopulation, you can see that the percentage of the positivity rate keeps increasing, and the TPR also increases for the 41 to 65. And while for the males, it remains more or less the same, but for females, it increases. And it's also the same. It's not 0 anymore. It has increased also for females over 65, while it remains more or less similar to males. So the male TPR remains the same, while the female TPR increases significantly by populating women with higher earnings in the 42 to 65 slice, for example. And the most important thing, of course, for a model is your F1 score. And thankfully, in this example, the F1 score remains the same, both for the holdout data set and also for the synthetic data set. The augmented data set is the synthetic data set, which is 0.86 and 0.86. But this is not always the case. So because this is also a bit of a, let's say, a complex task where if you do populate your synthetic data set with, let's say, desirable, or you're actually introducing your own bias, but a positive bias into the data set, the F1 score might not always be as good as the previous one, because in the holdout kind of reflects the reality. So this is where the tension might come. So do I go for a more fair data set, or do I want my F1 score to be higher? So in this example, of course, we showed you the perfect example where the F1 score remains the same for both. But the trade-off in this, I'm not, of course, going to say that synthetic data or even fairness metrics are going to save the problem of save the world from the problem of AI bias. So this is the trade-off which data scientists or managers need to understand while implementing fairness metrics. And a very important aspect I would like to mention with respect to fairness is that it cannot be fully objective. It's not something that you can count and keep optimizing or improving. And like William Bruce Cameron says, this quote is wrongly attributed to Albert Einstein: not everything that counts can be counted, and not everything that can be counted counts. And that's perfectly suitable, especially for fairness metrics. And this is very important, because when you start thinking about implementing fairness metrics in your data pipelines or in your machine learning processes, do be aware of what is your goal with it. And what is your company's vision on it? Do you want to have fairer data sets? And you have to involve multiple stakeholders in your decision, because you can't just say, I'm going to make this data set bias-free. And do focus on data quality, because that's an important parameter for not just fairness, but also the general performance of the model. And testing is very important. Keep testing testing, try to check with different slices, different ways of augmenting this to go forward. And please do remember that there are no perfect ways. It is an evolving field, and they're not deterministic. Nothing is deterministic here. And it seems like, I know for engineers, if you say, oh, it's complex, it's a multidimensional, multi-stakeholder, it seems so complex, but it is a complex topic, so we don't want to have simple answers here. And before I conclude and have some time for questions and discussions, I would like to remind you again that we are only talking about the statistical and computational biases that we can fix, hopefully, but they are coming from a much more deeper system of the societal and human biases. So I would like to also give you some reflections, take-home messages that, of course, we can fix, but techniques like synthetic data could actually help to change the human biases if, as computational professionals, you can actually change the data sets and set a positive reinforcement loop into the society and back. So with that, I'm really happy to take questions. And if you have more questions that we cannot answer now, happy to do in the Slack channel. So thank you for listening. So.
Yeah, thank you, Shireen, for this interesting talk. So maybe someone who is with us in Zoom can have some questions. Nobody.
Maybe we will get it on Slack later. That's fine. We can also have a non-synchronous discussion as well later. But yeah. I'm happy that I know it's not an easy topic to deal with, and because it's not fully quantifiable, but there are methods to do it. So I'm glad to have discussed it with you.
Okay. So if we don't have any questions.
Oh, no, there is one. He's typing it.
Okay. You can unmute and ask the questions live. Okay, we'll wait.
Yeah, we will
wait.
Question. We'll wait for the question, and while we wait for it, actually, at the end of this month, we will also release an open source library with the work that we have done on the fairness metrics. So it will also be more easy to, feel it in real life, not just I will let you know. I will post it on the Slack channel when that's open source.
Okay, we can do some blog posts on our website about this library. Why not?
Excellent question. That's an excellent question. I'll just read out to the ones who don't have access to the chat. How can we make sure that companies consider fairness while deploying ML models, machine learning models? Is there regulation currently regarding this? Excellent question. To some extent, the GDPR does require a level of transparency and accountability. It doesn't go far for algorithms, but soon there will be an AI regulation, AI Act it's called. It will come in 2 years, where the European Commission requires companies to have kind of an impact assessment, a risk assessment of their models. What is the impact? And there is also a technical checklist for them to go around, and fairness is one of the requisites. So they need to show that the algorithms don't discriminate. So there are many regulations that are they're coming up, not just in Europe. I can talk about Europe because it's where I am from, but also colleagues in the US say that, like, the Federal Trade Commission also constantly looks at the algorithmic audits. So definitely there is a lot of interest also in companies to be responsible, both from a reputational point of view, but also in terms of ESGs, they call it, in terms of sustainable goals. So there is interest, but it won't be immediate. Until the law comes, everybody will be like looking and waiting and watching, but some are going forward. There is a motivation, definitely. Has another question. Has your team faced challenges convincing regulators to adopt these techniques? What advice would you give teams to working to meet regulatory expectations in the fairness privacy space? That's a brilliant question. One thing is that in terms of privacy and fairness, especially regulators are also quite aware of the new technologies. And if you look at, for instance, the European Data Protection Supervisor, they do have a section called Tech Sonar, where they talk and discuss about the newest technologies that can help either privacy or fairness. And most recently, for instance, they also agreed on some kind of an audit methodology to approve for a privacy metric. So regulators are not as backward as we think, not the ones who wrote it, but there are teams of people working with them. And there are many ways to engage with them, either through working groups or focus groups. And also what we noticed is, like, for instance, we are just starting out working with banks, and we know that banks have direct access with the regulators, the banking regulators, and some of them have some initiatives like data sandboxes. So basically, you can first test out all the difficult aspects in the data sandbox environment before making it into public. So they're obviously not as fast as tech companies, but I have to say it's not as bad as we think. Is that a partial answer to your question, Philip?
It's possible to unmute.
Okay. Yeah, you're right. You're right. Not all regulators are there, but we cannot. I have a feeling that even without regulation, there are some things that are also smarter to do it by design. If you do fairness by design or privacy by design, you will be ready whatever comes. That is my attitude as well.
Okay, I think.
Okay.
The two guys who was with us in Zoom asked their questions. Anyone, not someone joined, but not stay with us on Zoom. So I think we can continue in Slack. If someone have more questions, let's continue in Slack.
Okay.
Again, thanks for this presentation and interesting topic. See you all on the next webinars. We will announce in near future about our next webinars, what we have next. Thank you for all.
Thank you. Thank you very much, and hope to connect with you on Slack. Bye. Have a good.
Yeah.
Bye-bye.
Bye.